Welcome to my vlog on cybersecurity and big data. My name is Lipyeow-Lim. I'm a computer scientist and educator and a software engineer. I've heard from some of my friends and customers as well, and asking me, hey, can we actually write apps on top of Databricks? It seems like Databricks is mainly for notebooks and maybe some dashboarding and SQL editor, but can we actually build apps on top of Databricks? So I'm going to answer that question today by actually showing you how to build a simple app that will do uh, visualization of attack paths and things like lateral movement using graphs on top of Databricks. So the idea is this, right? That I'm going to ingest Azure AD data and Okta data. These are all authentication data, and I'm going to process them into triples or edges, do aggregation on them, and then create a view to unify all the edges from the different data types, data sources. I'm also going to run a entity resolution package. You can use a favorite one. One example is Zingg. In this case, for this demo, I just hard-coded these. Basically, the entity resolution package will give me same as triples. It will figure out, hey, this email address and this email address are actually pointing to the same person. And you will encode that as same as triples. And you realize that this makes it extremely powerful if you want to visualize attack paths and see, hey, when one email address or one account has been compromised, maybe its credentials got stolen, or through phishing and malware, the credential, again, is stolen, and the attacker can log into the credential and start moving laterally in your environment. How can we actually visualize this and actually try to investigate this? So that's the goal of this app. And again, Databricks is not just notebooks. In this case, I'm just going to use the Python connector, the Python SQL connector for Python. Again, the documentation is here. I'm not going to go through that. I will actually go through very quickly the code somewhat. What I'm doing is, in fact, you actually saw it in this picture, right? I create a GraphQL server that will back my React app. My React app is just going to be sending GraphQL queries to the GraphQL server. The GraphQL server will relay those queries to Databricks. And I'm keeping it extremely simple and generic. Let's take a look at the GraphQL server code. This is the GraphQL schema. I'm just creating a single query endpoint called getData. It takes a string endpoint. The endpoint basically specifies which Databricks workspace you're going to query. Takes a query string, which is a SQL query, and arguments to that SQL query, returns the table, which is the result of that query. And what it is, the implementation is fairly simple. It's just using that Python SQL connector. It's going to open the connection, generate the query string and by filling in the arguments, and send that query to that connection using execute query, and then brings back the results. And then if the result is not empty, it's going to return the results as the GraphQL results to the UI. So I have this server running on my laptop. I also have the React app running on my laptop. The React app is going to execute a fairly complicated SQL. That's why it's not really instantaneous result, because it's actually doing some fancy matching using the same as entity resolution results to actually try to find equivalences. And it's also treating the graph as an undirected graph. So I actually have to duplicate the edges in both directions at query time. So the query is fairly involved, but you can see that I can still have a decent experience using that. So let's jump right into the demo. This is my React app, and we start with a search input. And in this case, suppose by looking at my EDR solution, I saw that, hey, there was some suspicious activity on the account Megan Chang on July 20th, 2022. I'm going to pull back the edges, and this is going to send a query to Databricks workspace, and it's going to pull all the edges that either has Megan Chang in its subject or Megan Chang in its object. And right now, my workspace, I think the cache has probably gone cold, so it has to sort of repopulate the cache, so it might take a little bit longer. So it brought back the results. I'm using a very simple open source graph visualization package. But which is again very generic, if you use one of the paid ones, you get a much nicer visualization. But this is what I managed to come up with. And also, full disclaimer, I am not a UI programmer, so this is definitely out of my comfort zone trying to create a React app. But okay, the gray nodes are the account identities. So we see that Megan Chang has a Okta identity, and Megan Chang also has a Azure AD identity, and there are different IP addresses in orange associated with each identity. And we saw that the two identities are connected by a same-as edge that's been found by our entity resolution package. And the dark blue nodes are apps, the light blue nodes are resources. And this lets you then discover, hey, wow, actually, if the Okta identity for Megan Chang has been compromised, this identity might be able to get to the Azure AD identity as well. And so all of these resources might be compromised as well. Now, suppose I also found that Maria Cook or Maria Cole, it's another suspicious credential, if you will. Now it brought back the edges from Maria Cole, and which one is Maria? This is Maria Cook, and this is Maria Cole. Now, why is Maria Cook and Maria Cole connected by a same-as edge? This is very interesting. Well, it turns out that, and look, this is summers.info. It's not even changfisher.com. So it turns out that summers.info was acquired by changfisher.com, and Maria Cook got married and changed her last name to Maria Cole to take on her husband's last name, for example. And again, but these two identities still exist within the IT systems. And so again, this actually shows you that your surface area might not be what you originally thought it was, right? And we see that the Maria Cole and Megan Chang, they do share some common apps and some common resources. So these could be pathways that the attacker could actually pivot from one credential to another credential. But more interestingly, oftentimes attackers will pivot through via machines. And I'm just going to pull back this IP address. I click on this, it will fill out the node ID for me. And I'll click add edges. It's going to bring back all the edges for that IP address, which in this case, let's see, where did it go? Oh, it's here. It's this IP address is also used by Peter Ruitz and Carl Schutz. By the way, this is all fake data, so I'm not exposing any PII here. Just to be completely clear. And you get the idea. I can keep clicking and keep going on. But this tool also lets you actually dive in a little bit into the details. All the edges that are pulled back are displayed in a table here, so you can deep dive on it. You can look for certain IP addresses and look at certain IP addresses. You can look at failed logins. You can look for particular IP addresses like this one, for example. And then if you want to actually, again, these are the extracted edges. If you want to deep dive into the raw data, I can actually do something pretty nifty. I can click on this icon here, and it will pre-populate this query for me to get the raw details. I fire another query to Databricks, and it is going to bring back all the raw logs in this raw JSON, and there are 10 of them, and I can actually deep dive into the JSON logs here. Anyway, so this is a sample app that I created. It was pretty fun, and it's a pretty cool app as well. It's definitely not a production-ready app, but it does help to show the art of the possible. Hope you enjoyed this episode. Thank you very much. See you next time.